just go ahead and get started. Our objective for the day is compound inequalities. You will need some background information on equalities. This is before this class, but I wanted to go back and give you an idea of what's going to be important. Things to recall is we're going to solve them like linear equations. Always remember to flip the inequality sometimes. When do I flip the inequality? This box here tells us when we're going to flip the inequality. Most people like to put their x on the left. So if you switch it around, if it says 3 less than x, and you switch it around to x greater than 3, you see they flip the inequality. And then also, when you multiply and divide by a negative number, it also flips the inequality. So a good note for this one, if the coefficient with the variable is negative, then we are going to flip that inequality sign. They've got a couple examples over on your resource over here. A real simple one, we know about negative 3x is less than 9. Okay, well, the coefficient in front of the variable is negative. So therefore, I am dividing by a negative sign, which means this guy right here is going to have to flip. So we flip the inequality when we multiply and divide by a negative number. You probably remember this one. If my inequality signs do not have a line under them, then I'm going to graph that with an open circle. If they do show equality, which means there's a line underneath it, then I'm going to graph it with a closed circle. We also have infinities. Now, how do we do this with this interval notation? The interval notation says if it does not include it, we're going to use parentheses. So we'll use parentheses on this. If it does include it, we use brackets. And you'll see that as I'm going through here. Also, I have that interval notation video in your playlist that will help you do this interval notation. And then with the infinities, we always use parentheses. We need to know the difference. Most people know this, but if this was 0 with our negative number and our positive number, if I go all the way down this way, I am going to negative infinity. If I'm going all the way this way, I'm going to positive infinity. Okay, we're going to do a little bit of review right here, and then write it. The first step, write this in interval notation. So, number 1, it has a line under it, which means it is a bracket. Interval notation tells you, after you watch the video, you'll know more about this. You put your beginning point and your ending point, but you'll notice that the 1 does not have a line under it, and so therefore it would be a parentheses. And number 2, we're going to start at 0, end at 2. The 0 has less than, so that's a parentheses. The 2 has less than, so that will also be parentheses. You'll notice there's no inequality lines in this one. Number 3, let's show a little graph on this one. If I was at negative 3, I would be doing an open circle because it doesn't show equality, and it says x is greater than. So if you think about where you started at negative 3. It doesn't include the negative 3, and it goes all the way to positive infinity. infinities have parentheses. So here's number 3. Okay, I'm going to come over here and graph number 4. You see we've got 2. It is a closed circle because you'll notice it shows equality. There's a line underneath that, and it's telling me that all the values of x are less than or equal to. So we're headed to the left. How do you write that with interval notation? Negative infinity. That's where we started. If I keep going to the left, I get all the way to negative infinity. Where did this graph start? Stop at 2. And it stops at 2 with a bracket because we have a closed circle. Number 5 and number 6 is just going backwards to let you get some practice on solving inequalities before we head over to compound inequalities. So I was going to solve number 5. Got negative 2x plus 3 is less than 1. First, I got to move my 3. It's on the wrong side. So now I am left with negative 2x is less than negative 2. I divide by a negative 2 to get this going over here. And what happens when I divide by a negative? I have to flip my sign. And negative 2 divided by negative 2 is 1. So if I was going to write this in interval notation, I know that all values of x are greater than 1. Some people like to draw this first. It might help you. This is an open circle, and it says greater than. So therefore, all the values of x start at 1, end at positive infinity. On 1, I have a parentheses, and on infinities, I always have parentheses. Okay, number 6 is 7x plus 4 less than or equal to 2x minus 6. I'm going to bring my 2x over to the left side. Those are gone. 7x minus 2x is 5x plus 4 is less than or equal to negative 6. Subtract 4 from both sides. I get 5x less than or equal to negative 10. Divide by 5. And I have that x is less than or equal to negative 2. If you want to see the graph of that, at negative 2, we have a closed circle. We have a closed circle. And then it says all the values are less than negative 2. So therefore, we're going to graph the left. And if I wrote that in interval notation, I start at negative infinity and end at 2. And 2 has a bracket since it is closed circle. Okay, just in case, here is some examples of what a graph is going to look like in compound inequalities. You're going to have, instead of one thing going one way, you could have more than one. So here is some of the ways that you write compound inequalities. All right, in number 7, it starts at negative infinity because you see, and then it stops at negative 3. At negative 3, I have an open circle, so I'm going to use a parentheses. And on infinities, I always use parentheses. And you'll see that thing has a gap right here. There's a gap. And so I switch over, and next I pick it back up at 0. And then it goes all the way to positive infinity. Now, the way that you show that these two graphs go together, you put a U in the middle. So this is interval notation explaining when you have two parts that are separate. In number 8, it looks like I started at negative infinity. I stopped at negative 5. It does parentheses, and it does not include the negative 5, so I put parentheses. In number 9, it looks like my graph is graphed between two numbers. And so my beginning point is -3. My ending point is +5. On the -3, I have an open circle, so that's parentheses. And then on the 5, I have a closed circle, which is going to be a bracket. And number 10, you'll notice that at 2, we have some stuff going this way. We have some stuff going this way. And so basically, every single part of that works except for the 2, because you'll notice that there is an open circle at 2. And so we will union that, negative infinity to +2, doesn't include the 2, and then it jumps over again the 2 and goes to positive infinity. I'm going to put y'all another one that piggybacks off of that. Let's say I had the exact same graph, but at 2, it was a closed circle. But it definitely shaded to the left, and then the other part shaded to the right. In this case, my answer is the entire number line. If you have the entire number line, you write your interval notation like this. If everything in the number line works, then we'll put negative infinity with infinity. A couple things. You got this Venn diagram that will show you what and or means. Let's start on the or. The or means that the solution could be in either side of the inequalities. It could be on the A side, it could be on the E side. It also refers to the union of the inequalities. And so the union will take an account for everything. It is signified by a U, and then the answer is everywhere you see a graph. And if you'll see in the pink section, our or right here, if we pick or, then that means you're graphing the entire thing, what would work in both of your inequalities. Okay, if we pick and, the solution has to be in both. It can't be in A, can't be in the B, it's got to be in both. So that refers to the intersection. The intersection you'll see in the top graph. That top graph helps you out a little bit. A and B are both sets. We have an intersection, which is and we have a union, which is or. The both with the and is signified by a U that is upside down, and that is everywhere you see both graphs. Okay, let's discuss what that everywhere means. So in the first little picture here, if I see, where do I see a graph? Everywhere. If I was doing everywhere I see a graph is or, both is the and you have to see both graphs. So if I name these A and B, if I was doing or, everywhere I see a graph, well, I see a graph from negative infinity to -3. It doesn't include -3 because that is a circle. It unions and picks back up at +5 and heads all the way to positive infinity. If I looked at this as a and problem, both graphs, there is nowhere that these graphs are overlapping. And so therefore, if I was doing an and right here, my answer would be no solution, because there's nowhere where these graphs are on top of each other. You will see in B where they are on top of each other, and you can see what that looks like. But in A, there's nowhere where they're both graphs. Okay, let's go on to B. Or, everywhere I see a graph, Well, I got an arrow right here taking me all the way to negative infinity. I've got an arrow right here taking me all the way to positive infinity. So therefore, everywhere I see a graph is negative infinity to infinity. You only have to see one line for your ORs. Okay, and if I'm doing and, the only place where I see both graphs is right here. They're on top of each other. And so my and solution would be I started at -3. It didn't include the -3, so I used a parentheses, and it ended at +5. And that also was an open circle. So you can see all they got to do is change the word in the middle. All they got to do is say or and it can totally change the answers to these problems. Next, what we're going to do is head over to some and or examples. All right, let's see this in action. I'm going to head over to the or examples first. Or, and I've got you the picture at the top so we don't get lost. The notes from the last page, we know that or is the union, and as long as I see one line, then I am good to go. The union means everything. It could be in that set, it could be in that set. It really don't matter. As long as it's in set A or B, then you're good. All right, we're going to solve these like one-step equations. We'll do one at a time. +5 plus 5. So I have 7v is greater than or equal to 70. I divide by my 7. I haven't divided by a negative, so therefore I don't have to change the sign. And I get that v is greater than or equal to 10. Okay, if I do the other side, -3b minus 2 is greater than or equal to -2. I'm going to add 2 to both sides. I have -3v is greater than or equal to 0. I'm dividing by a negative. We talked about what happens when you divide by a negative. So therefore, my inequality sign is going to flip. Like this sign flipped up, it flipped the other direction. So now I'm going to graph these. I know I have one number at 0, one number at 10. On the 10, I have a closed circle. Z is greater than 10. So that's to the right. Then I have a closed circle at the 0, and it's telling me that V is to the left. Okay, union says as long as you see one line, you can count it in your union. And so we see a line, our final answer, we see a line from negative infinity to 0. Union, that was a closed circle. That was a closed circle, so therefore that is a bracket. And then at the 10, we pick up on a bracket again for 10. And then we head all the way to infinity. Problem number 1. So the solution will be written in integral notation. Okay, number 2, I want to subtract 6 from both sides. So I get 7m is less than 6m minus 11. I subtract the 6m from both sides, and I'm left with m is less than -11. So at my negative 11, I have an open circle and it's less than. Okay, if I do the other problem, I'm going to add 7 both sides. So I have 3m is less than 12 plus 6m. Subtract my 6m from both sides. I have negative 3m is less than 12. Now I am dividing by a negative. So when I divide by a negative, I have got to turn that sign around. So m is greater than or equal to negative 4. So my negative 4 is up here somewhere. I've got a open circle at the negative 4, and it tells me that it is greater than. So therefore, my solution, it starts at negative infinity. It stops at negative 11 with a parentheses from the open circle. We union that with an open circle negative 4, then head to infinity all the way to the right. Okay, number 3. Number 3, there's no math. It's ready to graph it. I've got a negative 2 and a positive 3. It says at negative 2, I have an open circle and it's greater than. For the 3, I have an open circle and it's also greater than. And so don't forget that the OR problems are everywhere you see a graph. Where do you see a graph? Well, I start seeing one at negative 2, and those graphs both of them go to positive infinity. Negative 2 will have a parentheses due to it having an open circle. Looks like I need to subtract 8x from both sides. So I got negative 7x plus 18, that's gone, is greater than or equal to 4. So I next am going to subtract my 18, and I have negative 7x is greater than or equal to negative 14. I'm going to divide by a negative 7. I divided by a negative. So since I divide by a negative, I have got to flip my sign. So at 2, I have a closed circle, and it says everything of x is less than 2. Okay, I'm going to do the other problem. I'm going to pull that 16x over. I like to put my x's on the left side. Those are gone. That gives me negative 1x minus 15 is less than or equal to negative 5. So I'm going to do plus 15, and I have negative x is less than or equal to 10. I'm going to have to divide by negative 1, which flips my sign. So I have a closed circle at negative 10, and they tell me it is greater than. Okay, everywhere I see a line. Think about this very carefully. Yes, we have some overlapping areas, but everywhere you see a line is all the way. You'll notice those arrows on the end. So therefore, this answer would be the entire number line. Okay, let's head over to and then. And examples mean the intersection. They mean that you have to be in both. For example, you could have group A is your people that play football. Group B is your people that play basketball. But do we not agree that some basketball players also play football? Or maybe group B was baseball. Some football players also play baseball or run track. And so you got to know that there's an intersection in the middle because you belong to both groups. So what do we have to see when we graph this? We've got to see both groups or it will not work. Now, how do we solve number one? This is a compound inequality that is written where we need to get P in the middle. We've got a 2 down there, and so I need to get that P all the way by itself in the middle. The way that I handle these is to get P by itself. But you have to do something to both sides. In this particular case, I'm going to multiply both sides by 2 because you'll see it'll cause that 2 to go away. So I'm left with -6 less than or equal to P, which is less than 0. Now, how is this graph? We've got a -6, we've got a 0. It looks like at -6 we have a closed circle, and at 0 we have an open circle, and it says our answers, everything that's with P is in the middle. It's between those two things. So to write our solution in interval notation, where does it start? It starts at -6. It includes the -6 because that's a bracket. Then you put comma, and then you put where it ends. It ends at 0, but it does not include the 0. Therefore, the 0 has a parentheses. Okay, number 2, I'm going to subtract my 9 over here on the right so that that's gone. I have -12r is greater than or equal to -108. So then I'm going to divide by -12. I have to flip my inequality. I have to flip my inequality because I divided by a negative number. So therefore, I have R is less than or equal to 9. So at the 9, I know that I have a closed circle, and it says that R is less than 9. On this side, I want to add 4 so that those disappear. I have -2R is less than -8. So now I divide by my -2, and I have R is less than, because I divided by a negative, so therefore I had to flip my inequality. I did divide by -2. And so at the 4, I have an open circle, and it says greater than. Okay, you've got to remember that you have to see both graphs. You got to see both graphs. The only place you see both graphs is between that 4 and that 9. What's to the left of the 4 and what's to the right of the 9 does not apply to this situation because we're doing and problems. And so the only place where you see both of them is from 4, 9. The 4, did the 4 include? No, the 4 did not include equality. It was an open circle. And the 9 included equality, so I put a bracket. You'll notice this one is already solved. You will also notice that number 3 and 4 are the exact same questions that I pulled from the OR. I just wanted to show you that, like here we got number 3, 2, and 3. If you head over here to your OR examples, your number 3 is the exact same question. The only difference is I put and in there instead of or. So watch what happens just because I changed it from and or. Okay, let's start with the first one. I've got a -2 that has an open circle, and I'm going to graph it greater than. Okay, at 3, I have a closed circle, and it says all the numbers are greater than. Remember, and you've got to see both graphs. Got to have both when you're doing and. And so you'll notice that the only place we start seeing and is from +3 up. So this solution would start at 3 and end at +infinity. It includes the 3, so I'll put a bracket, and then it goes straight to infinity. Infinities always have parentheses signs. Okay, I am going to take a picture. All right, in the green part, I added 5 to both sides, got 70, brought my 7v down, divided by 7, and got that v was greater than or equal to 10. So at the 10, I have a closed circle, and it says greater than all the way. Okay, on the other side of the equation, we added 2 to both sides, and then we divided by the -3 that was in front of the v, and we had to flip our sign since we divided by a negative. So at 0, we have a closed circle because it shows equality, it has a line, and it says that it is less than 0. You see both of them. You're going to see both of them on top of each other. Do you see the red graph and the green graph? Do you ever see them on top of each other?
Can you repeat it?
No, Flo got it. Flo, he said no. Okay, so if I don't see anywhere that they overlap, then what do you think my solution is? Is there a solution?
No, there isn't.
So what would I write? Do you know? He said there's no solution. So literally, you just write no solution. And you're right, Flo. There is nothing there that overlaps. Nothing overlaps, and so therefore we have no solution. All right, Flo, I'll put your name down on my list. Thank you for that participation. All right, so welcome to compound inequalities. You notice that twice I gave you the exact same problem. All I did was change the and or the or. And so be careful of that. That one little word could change how you do it. Hopefully you learned something.